All right, AJ back at it again with OttoCRM, the AI-enabled CRM and customer support bot system that I'm building over at Gauntlet right now. And last time we showed you all of the regular features that we implemented, metrics, tickets, knowledge base, and so on. And this week we're adding AI features and reporting out on that. So we have obviously, again, to review our knowledge base, which has documents, aka uploaded PDFs, and articles, which are kind of the same but written on system. What we did this week is basically used AI system that can do RAG on this so that an agent can help customer support agents answer these tickets. We also wanted to collect like metrics on this stuff, log it in Langsmith, and like get some numbers about like accuracy, latency, that kind of a thing. And so we did custom annotations there, created like 30 new tickets that we responded to using the system. And then we also have one that I reset in order to demo what that workflow is like to y'all right now. So without further ado, going into this new ticket that just came in, you see they have like the request. We have the ability to open the ticket, which will change the status and send a message from the agent that's operating the system. And it can, like a normal CRM, respond in chat. But we also have our smart features. So we have get suggestion, which will actually go through a workflow with a suggested response that I can edit and then send. Or I can choose to auto send it, in which case we'll just send suggested response directly. So I'll demo that for you now. Basically, this is going to make, it's going to take the chat history, rewrite everything in order to get a better query for RAG. Then the RAG documents that it has will be used to formulate a response, and it'll have citations for where it got that info. And then as you can see, it automatically checks off which of the RAGed items we want to potentially include as a separate message to pass along to the user, as well as its recommendation on whether we update the ticket to pending or not. So all this is like optional. If I use check use suggestion, I'll be able to edit this before sending. But we can also do the fully automated version, which does all of the same stuff on the back end, except instead of providing it for me to edit afterwards, it'll automatically send the messages and then use like tool use on our API in order to update either status or the API also has priority, but we haven't implemented that for tool use for the LLM just yet. Okay, so like as we can see, they asked about the warranty, and we correctly pulled up the warranty documentation, we're able to read it, and then find out that it doesn't actually specify the thing that they were asking about. So we correctly answered their question, or at least the LLM, to the best of its knowledge, gave the right response to their question, which is how we're doing the grading. And so we jump over to here. This is Langsmith. This is data on the 30 queries that we responded to with the system. We have one for whether it correctly updated the status and one for response. This is a time series. I couldn't figure out how to get this data into a dashboard like this without doing a time series. There's probably a better way to represent that. But the long and the short of it is that on the judging the accuracy of the response, which is whether it answered their question or whether it correctly told them that we don't have the answer to their question, it successfully did that 93% of the time. And status update is lower at 80% of the time. If I were to run this experiment again, I think it probably would make sense to actually differentiate between different cases in terms of, especially for status update, where it can correctly respond and then update the status for that. It could correctly respond and then fail to update the status correctly, or it could have a conversation that could continue and need in error update the status, right? So there's both false positives and false negatives. And the interesting thing here is that I think the hit rate for status update was, for the positives, was actually 100%. So that other 20% is almost entirely from the negatives. And I think about 80% of the time had false negatives. So it would be interesting to be able to like dive into like more granular data about that. But I didn't set up the annotations to capture that initially. So yeah, this is basically how the system is doing now, how we would go about like tracking. and excited to continue improving on AI models with this. Thank you guys for checking in.